Welcome to the first video for Module 6, covering Module 601, Representing Data. Module 6 is going to review data and statistics, and this is a very important skill because data and statistics is something that is used in everyday life. All right, before we get into some of the real-world scenarios, let's talk about what data is, and then we can go over some ways that it is used in our daily lives. So what is data? Data are collected from information about a given topic. Collecting data can help someone learn more about a particular topic and make conclusions. Data can help someone prove things or even surprise people. And there are times when data does not reveal anything new. The study of data is also known as statistics. All right, with data and statistics, there are lots of times that we can use this in our day-to-day lives and use this in our jobs. One example that I can think of would be with restaurants. So restaurants could collect data on how frequently different items on the menu are ordered. If they discover that there's a certain item that is not ordered very often and it's not very popular, they could choose to take that off the menu because that could save them money, because maybe it's an item that has unique ingredients, or it could also, so it'd save them money in that way. It could help the chefs with having a reduced menu. It makes it a little bit faster and easier them to cook things in the kitchen and get our food to us quicker. Another scenario is I can think about just different offices. No matter whether the office is a paper supply company or car manufacturing or auto dealerships, if they're presenting a new topic, they're going to want to have data to back it up to say this is why we should make this decision or why we shouldn't. They maybe are going to track different trends. Maybe there's certain times of the year where the product sells better than others. And so therefore they know when to jack up the price. And during those low ports, they could offer sales and discounts to try to bring more people in. So this is a very key part. Data and statistics is also used in science class. So I really am hoping that this module will be a great end to our distance learning for you all, since it has so many real world connections and it's stuff that you've maybe seen and experienced before. All right, let's officially get started. So one thing that we need to begin with is statistical questions. So the study of data, as we just learned, is known as statistics. So we need to realize that there are some questions that are statistical questions we can answer with data, others may not. So statistical questions specify populations and measurements of interest. The question should also anticipate answers based on data that vary, but they anticipate fixed answers, so no randomness is involved. The answers to statistical questions will address a variation of data, use probability statements, and apply only to the population specified. So I know that's a little wordy, but let's go into a couple examples so that way hopefully it'll be a little bit more clear for you all. But one of the key things is it needs to be based on data that can vary. But there's also no randomness involved. So there's a set parameter, but people can have different answers. All right, example 1. Determine if the following is a statistical question. So how many cars were sold each month this year? So in order to help me understand this, I need to think, is this something where I could collect data on it? The data could vary, so I'd have different numbers, but there is a parameter. It's not going to be completely random. Well, could I collect data? Could I go to a dealership and see how many cars were sold? Yeah. Would I have a parameter of answers? Yeah, because I could expect depending on the size of the town, my answer is to be within a certain range. It's not going to be like 1 million or negative 500. So yes, this is a question that would be statistical. Example number 2. Determine if the following is a statistical question. How many days are in December? Is that information that I can collect data on that will vary? Yeah, no, that has an exact answer. So that is not an example of a statistical question because I can look at a calendar and know how many days are in December. That's not going to change. All right, third example. What is the favorite subject of 9th graders at 5A high school? Well, could I survey people and collect data on that? Yeah. Could everybody's answers vary? Yeah. But would there be fixed answers, a parameter? Well, yes, because there's only certain classes offered at 5A, so that would give a parameter. So yes, this is an example of a statistical question. All right, now that we have reviewed data and the types of questions we can collect data on, there are 2 different ways that this module focuses on how to represent data. There's a lot of options, but we are going to focus on dot plots and histograms. So first, let's talk about what a dot plot is and how we can use that to represent our data. So one of the ways a set of data can be represented is by plotting dots over a number line. So that's why it's called a dot plot, because we plot dots over a number line. In a dot plot, the number of dots over the line tells us how many times that number occurs in the data. So each dot is how many times somebody picked that answer or somebody voted for that. So dot plots, therefore, are useful in comparing frequency. So they represent the frequency, how many times something's been created. So example 4. The following data shows the number of siblings each student in Mr. Lasante's class has. So that's a whole lot of numbers there. If I went to present this to you guys, I just kind of get overwhelmed. I'm like, I see all these commas. It looks like one huge number. It's just ridiculous. But if we create a dot plot, it's going to organize our answers and it's going to make the information more presentable. So the first step that we need in order to create a dot plot is we need to know what our range is. So what's our lowest and our highest value. So if I kind of pick through this, the lowest I see is 0 and the highest is 6. So we're going to go ahead and make a number line of 0 to 6. It won't be the prettiest, but that's okay. So 0, 1, 2, 3, 4, 5, 6. All right, that's it. 4, 5, and 6. So now we are going to place dots. Now it says up here, a dot plot, the number of dots over a number line tells you how many times it occurs. So as I go through my data, I'm going to put dots for the frequency. So I'll change my color. Oops. All right, so, and I'm going to cross them out as I do them. So if you guys are doing this at home, I really encourage you to have some paper next to you or maybe have the memo up on your phone so that way you can cross things out. So we have a 0, a 3, a 4, and we have 1, 2, 3 ones, another a 2, 2 3s, a 6, a 0, 1, 2, 3 more 3s, a 2, 0, and then 3 4s. And I just realized I probably could have used those stamps because I have the stamp feature to make my dots a lot prettier. Oh well, you live and you learn. All right, so now we have all this information and it's in a nice organized dot plot. So in looking at this, I can very easily see that a majority of the students have 3 siblings. Well, exactly how many have 3 siblings? Let's count it up, and I'll actually cover it up with a nice little heart. So 1, 2, 3, 4, 5. So 6 students out of in Mr. Lasante's class have 3 siblings. I can also easily see that nobody has 5 siblings. So that's one of the perks of organizing your data in some fashion. And dot plots are one of the best ones if you're comparing frequency, which is what we just did. We're comparing how many they each have. So what's the frequency? The highest is 3, the lowest is 5. All right, let's check out another example on dot plots. So here I've already created the dot plot for you. So the data in the table shows the resting pulse rates were recorded for 16 boys in gym class before they exercised. The data has also been organized into a dot plot. For which number are the data plotted incorrectly? So here I have my question. Well, they provided me, this time instead of with a list of numbers, a frequency table, but they also organized it in a dot plot. So I need to compare and see which one was done wrong. Well, here it says, so 79, there are supposed to be 2 boys that had that as the resting pulse rate. Yep, that matches. All right, then for 80, there's supposed to be 4. 1, 2, 3, 4. Yep, that matches. All right, for 81, there's supposed to be 1. That's correct. All right, for 82, there's supposed to be 3. Yep, that's right. For 83, there's supposed to be 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Ah, so I think we just found our mistake because they were supposed to be 5, but there was only 4. Let's just go ahead though, because this is a quiz that I don't want to retake several times when you're doing your quiz, and because I, in this case, want to make sure I pick the best answer. Let's verify real quick. All right, well, I'll have to start over. I'm out of stamps. So 0 for 84. Yep, 0. And then 85 is supposed to have 2. Yep, there's 2. All right, so our final answer here is the data for 83 was plotted incorrectly. Oops, I spelled that. I typed that wrong. There needs to be an additional X or an additional dot. It's just sometimes, as you saw up above, dots can get messy, so people will use X's instead, but it's still called the dot plot. All right. Now, before we move on to histograms, I'm recording this on Monday, May 4th, which if you're a Star Wars fan is called Star Wars Day because may the 4th be with you, may the Force be with you. So I got a little Star Wars joke for you. All right, why can't you email a photo to a Jedi? Because attachments are forbidden. Real knee slapper right there. And if you guys didn't get this joke, then if you have the ability to, since you're on quarantine, after you get all your schoolwork done, you need to watch the movies and not just the new ones, all right? Even though this meme is from not one of the better movies, but Oh well, you live and you learn. All right, let's talk about histograms to finish this off. So another way that we can represent data is instead of a dot plot, we could organize it as a histogram. Now actually I'm going to scroll real quick to show you a picture of a histogram. So this is an example of one, and it's similar to a bar graph, but it is not the same thing. Bar graphs are different than histograms. So let's review what a histogram is. So a histogram shows numbers in ranges. So sometimes they're called intervals along the x-axis. So this makes histograms appropriate to display numerical data such as weight, height, or time. So these are all examples of quantitative data. One of the reasons for that is it's an interval, because if we're talking about weight, your weight can fluctuate within the day, all right? It can fluctuate by either a decimal point or it can fluctuate by a whole number. And if we're talking about height or time, all of those we usually, because it grows so quickly, we have an interval. So we could say, like for wrestling, with the different categories, you need to be within the weight category, the weight interval of 100 to 115. So if you fall within that interval, you're good to go. Or on amusement park rides, you have to be above a certain height. So we could just create two different intervals, below that height, above that height. So a lot of times it's when you have that teeny tiny range, that teeny tiny interval. That's a good aspect and something that would cue you into, hey, I should probably use a histogram to represent this data. Now, remember that even though histograms and bar graphs look similar, they are fundamentally different in the type of information they display. Another thing, just by looking at them, that you can tell they are different, because in a bar graph, they're separate. But in a histogram, they're generally right next to each other. So that's another key if you're trying to differentiate between the two. So bar graphs are ones where they're a little bit more similar to a dot plot, where we'd be talking about frequency, where histograms are where we have different intervals of information. All right, let's get into that example that we just saw down below. So we want to know which one of these histograms represents the data in the table below. Before we get into that, let's just look at A and talk about what makes this match all of those verbal descriptions we just talked about. See how we have different intervals here? So 4 to 8, 9 to 13, 14 to 18. So we have those intervals. We have those different age groups. Also, I can see that all of my bars are touching. So that's another sign that it is a histogram and not a bar graph. All right, so let's see which one of these represents it. Let's go ahead and start with A. So I have my table of values right here. And I see that in interval 4 to 8, there was a frequency, so 8 people fall within this category. So if I look at option A, I want to see if in the interval 4 to 8, there's 8 people. Nope, looks like there's only 5 people. So can A be the correct answer? Yeah, no, that does not match. All right, let's check out B. So 4 to 8, still again, only 5 people. So nope. All right, C. That's kind of hard to read. Like, it looks like it's 7, but see, like I keep, getting closer to the computer screen. I keep trying to see it better. So let's check another one just to see, because it could be 7, could be 8. So in the 9 to 13 range, 3 people. That does seem to work. The 14 to 18 range, 10 people. Right there. That is clearly not it, because there's only 6. All right. So that just for sure eliminated C. I was iffy on it. That told me can't be it. So D has to be my winner, but let's double check. We don't want to just click it and move on. We want to verify that this is the best and correct answer. So 4 to 8, 8 people. Oh yeah, that lines up much better. 9 to 13, 3 people. 14 to 18, 10 people. Good so far. 19 to 23, 5 people. Perfect. So D is the histogram that represents this data. And one of the things is I know that you guys may not have the ability to annotate your computer screens, but you can, zoom in. You can hover your finger. You can take the eraser or the non-writing part of a pencil and kind of trace over that to help you line up and pick the best answer. All right, let's do one more example together. Example 7. Let's see, will this let me zoom? Okay, so the histogram below shows the number of people that visited the library last Wednesday. Clearly, this is old data because obviously nobody went to the library last Wednesday. All right, so it looks like we have our different age groups. So we have our different intervals. And I notice my bars are touching. So that kind of helps cue me in. This is a histogram because we have intervals of information. So we're still dealing with frequency, but we have an interval of information, which is one thing that would cause me to use a histogram instead of a dot plot. So we want to know which of the following statements best compares the height of the bars of the histogram. Well, for me, I want to jot down the frequency for each one of these. So I'm going to write on my histogram bars, but you guys on scrap paper beside you could make yourself a little chart, and actually I'll do both so you guys can have a good visual example. So for the 0 to 19 category, it looks like there's 9 people. So since you guys couldn't write on the screen, you could make yourself a little table. So for the 0 to 19 category, it looks like it has a frequency of 9. Now for the 20 to 39 age group, it's a little hard to read, but I think it looks like it's 6. So then the 20 to 39 has a frequency, I'm just going to abbreviate that, of 6. 40 to 59 looks like that'd be 11. So 40 to 59 has a frequency of 11. And last but not least, 60 to 79, looks like it's at 3. So 60 to 79 has a frequency of 3. All right, I'm going to have to be OCD here and line these up because this is way off. There we go. That's prettier. So that's just a little tool I would recommend because then the numbers are right there. You don't have to accidentally mix the numbers up, or you're not re-looking and counting every single time. So we want to know which of the following statements best compares the height of the histograms. So whenever I see best compares, I know it. I better read it carefully because it could be a little tricky. So there are less participants in the 40 to 59 age group than the 20 to 39 and 60 to 79 age groups combined. Well, for option A, I know we have 11 people in this age group. And then there's 6 in the 20 to 39 and 3 in that one. So, well, 6 plus 3 is 9. So is there less participants in this one than this one? No, there's more. So that can't be it. All right, option B, there are more participants in this category. So there are still 11 people in the 40 to 59 age group. Then in the 0 to 19 and 60 to 79 age group. Okay, so 0 to 19 has 9 people. 60 to 79 has 3. 9 plus 3 is 12. So are there more participants in that age group? Nope, this time there's less, so that can't be it. All right, there are twice as many. What does twice as many mean? Yeah, it's another word for double, 2 times as many participants in the 20 to 39 age group. So 6 people are in that one. Then the 60 to 79, which is 3. Well, is 6 twice as many as 3? Yeah, because 3 times 2 is 6. All right, so I think C might be my winner, but it says I want to pick the best one. So I'm going to still read option D before I officially select it. But it's looking pretty darn good. All right, there are twice as many participants in the 0 to 19 age group. So that would be 9 people. Then the 60 to 79, 3 people. Well, we just talked about how 3 times 2 is 6. So what would it need to be to make D true? Yeah, there's triple the amount of participants, but it doesn't say triple, it says twice. So that means the best answer is C. All right. As you guys go on and take the 0601 module video, please make sure you take your time, read everything carefully, because that is a big portion of this module quiz. Is, as you can see, it's not that we necessarily did a ton of math. I mean, we just did a little right here, but it's more about being able to read and to understand and to interpret. So please take your time and good luck, guys. I know you got this.